Hi, good morning. Welcome to our webinar on revolutionizing construction, robots for a safer and efficient job sites. Uh, Construction is a very unique industry, obviously, and it is one of those industries that historically has been a little, slow when it takes to slow when it comes to innovation. But there's good reason for that. It's one in which risks are very tightly controlled, and so when there's a lot of risk involved in an industry, it takes a little bit. Technologies have to be more proven before they're adopted. So this also represents kind of big opportunities in construction. It's rife with opportunity for innovation, as long as those innovations have been proven to be successful in helping. So that's one of the reasons why we started this, wanted to do this website or this webinar was to show some of the ways in which robotics is helping to revolutionize the industry. So without any further ado, I want to introduce myself. I'm Patrick Fletchall. I am the Vice President of Business Development for SuperDroid Robots. And I am somewhat new into the construction industry, but fortunately I have our subject matter expert, Perrin Olson, and I'll let him introduce himself.
Thanks, Patrick. Yeah, I've been in the industry for almost 20 years on the marketing side. Spent my fair share of construction job sites and worked hand in hand with operations on things. And it's a really interesting industry. I've been very much a fanboy of construction technology and started working with SuperDroid Robots. It's exciting because we're bringing robots to the industry, and it seems like the more construction companies we talk to, the more ideas are generated. And there's such an acceptance for robots in this industry because they don't have this fear of jobs loss and things like that, because it's an industry that's basically needs to fill 1 million jobs every year, and it keeps compounding. So they need more technology. They need to be more efficient. And saw something just the other day on LinkedIn that was actually talking about the construction industry is actually less efficient than it was just 25, 30 years ago. So buildings are getting slower or built slower than they ever were, even though we have more technology. So
interesting.
Some of that is permitting and risk management, things like that. But it's just in scheduling. But we need to get more efficient as an industry. The control risk, as you mentioned, control profit margins, things like that. So super excited to talk. One of my favorite things to talk about is construction robots. So
great. Well, I'm excited to get started. So I think probably what would be useful to get started is that we can't assume that everybody who is in the webinar maybe is familiar with why even using robots.
Yeah.
So it's kind of good to take kind of before you kind of do a more granular deep dive, take kind of a step back and ask some of the more basic questions of why you use robots. What are they for? I mean, we have a general understanding what they're for, but we can do, being in the industry, we can kind of articulate a little bit more in more depth. So the common adage within robotics, at least within the robotics community, is that robots involve the 3Ds. And those are anything that involves dirty jobs, so stuff that is just nasty and not really fun to do. Dull jobs, which are monotonous and repetitive. And the thing about that is that it's not just a matter of being boring, but when a human becomes bored in doing the routines of a job, that's usually when there's less attention given to it, and that creates more opportunities for danger and harm. And then, of course, the obvious one, dangerous. And sometimes you can have one, sometimes you can have two. A lot of times you can have all three. And then we like to actually add a fourth category to that, which is it kind of overlaps with a lot of them, but we're seeing more and more, especially with existing technology, we're seeing a lot of demand for doing your job, but not being in the actual place that you're doing it. So distance. Perrin, do you have anything else to add on that?
Oh, I think everyone would agree that construction can be dirty and dangerous. And I think we sometimes glamorize or forget glamorous construction is your hard work thing. There's a lot of dull moments, and if you're going to build a 500 room hotel, you're doing something 500 times, so it gets very dull. And
yes,
so it's definitely something that's I want to bring in kind of people's mind, because most time people are thinking robots, they definitely jump into the dirty and the dangerous. We're trying to make our job sites safer, but we also want to make them more efficient. And the dull is very much one that people underestimate how dangerous that can really be. Anyone who's in a safety role totally gets that. How do you keep these people energized, things like that. And sometimes things that are dangerous might not be dangerous today because the weather's nice. But if it starts raining or it's super hot, we have 100-degree weather, 30-degree weather, that changes that level of danger. You and I were talking to somebody a while back, And he's like, I just want to, when it's windy, I'd love to have a robot just to go and inspect the top of the skyscraper working on to see what objects might fly away at X amount of wind speed. I was like, he wants either a camera or a robot up there looking for those kind of things just to make their environment safer, instead of sending somebody up there to basically go, yep, it's windy and what can fly away. So, how do we even help with those kind of warning triggers?
The dull one, you're absolutely right to kind of hover on that one, because I one of my jobs in college was I was a wood veneer puller, and pulling wood veneer is probably one of the most dull jobs you can possibly do. You are literally just pulling things off of a belt repetitively for 12 hours at a time. And when you do anything repetitive for literally 12 hours at a time, first off, I had the experience of not a single thought crossing my brain for 8 hours. But my colleague, who is, I call it colleague, but anyway, the person that was in front of me, you're supposed to pay attention to any of the large sword-like slivers that are coming off of them as you're pulling them. Well, he was just in a routine, and he was pulling one, and one of them went straight through his bicep.
Yep.
Just because it was boring and he wasn't paying attention.
Yeah, repetitive tasks. Another one we see in manufacturing a lot, which I know you've done a lot of work with, is just those repetitive manufacturing jobs. And construction, we forget, is a manufacturing, but we tend to build something for the first time every time. It's not the same widget that we're continuing to build in a manufacturing facility. So things are actually escalated because it's generally the first time we're doing something, and we don't necessarily control that environment. So
right. So in continuing on that theme, kind of going a little bit deeper in the dirty, dull, dangerous, and distant, is kind of talking exactly about what robots do for you. So most importantly, they increase safety, and we don't always like to talk about the dollar value that is associated with safety, but it's a fact of life that injuries cost money. Having vehicles that break down are both cost money, but also a vehicle that's damaged or has experienced wear and tear operating around people can create safety issues. So it's kind of a no duh that when you put a robot in an area where a person could be harmed, you are increasing safety. One example is a person I was speaking to that was obligated to, before using a robot, he was obligated to go into a space that was very, very small, had to be inspected, but it had a lot of moving machinery parts, and there had been an accident in it before, a horrific accident. And so nobody wanted to go down there anymore. So
I think one of the traps that happens in construction, we've seen this in manufacturing as well. It's always this mentality. We've always done it this way, and we've done it for 100 years this way. Well, yeah, we can do it a lot safer. Like you were telling me about the pallet shredder one time in a manufacturing facility, and it's like they got to go clean underneath a pallet shredder, and we're all like, that's crazy. But this facility's been doing this for decades,
right?
And finally, somebody kind of opened up their eyes and like, that's a huge safety risk. Or at the very least, now maybe even they knew it was a safety risk before, but now they're like, wait, we can actually do something about it now. Technology's caught up to the point where we can do something. And sometimes it's even, can we do something while machines are operating? There's sometimes you can't put a human there. We if we're used to these heavy machinery on the job site, there's a lot of times spotters and things like that. And there's kind of like no man's land. We don't want to have people in certain areas where we're doing things. But sometimes there's something that's got to get done, and most times construction people get the job done. That's kind of what they're known for. Well, sometimes it's really dangerous what they're doing, and they just kind of hope OSHA's not looking that day. And that's a perfect opportunity for robots. And I want to cover here this last bullet point too about the growing profits. Like profits isn't something we talk about in construction very a lot, but it's very important. There's usually very thin margins on a job site with a lot of risk and a lot of room for error. And if we can help control some of that or minimize that risk, that's really an opportunity for an improvement in this industry. Is if you're dealing off of like 3, 5, usually 5 is a high % profit margins for a job site. So there's just not a lot the wiggle room on that. So
anything that creates efficiency extends your profit margin.
Yeah, and I kind of talk about this next one about construction's one of these industries that's kind of embracing robots because we're not necessarily replacing jobs. We're replacing some really those dirty, dangerous, dull jobs, but those people are just getting used in other areas. But
now,
this is
correct me if I'm wrong. Sorry to interrupt you. I've heard that in the construction industry that they're having a hard enough time finding people as it is, that they want to retain the people that they have.
Oh, there's a few things. It's been at least the 2 decades I've been in construction. Basically, we've been short almost 1 million people every year, and it's not going away. It's improved. We've made headway, but every time we get a growth in recruiting, like with Mike Rowe's Dirty Jobs, did a great job of just kind of capturing what the industry can do, and bringing attention. Some of the associations like AGC and ABC have done a great job of recruiting people and making construction cool and interesting. Technology is actually really helping with that recruiting. But the problem is we have this baby boomer generation that's leaving and they're retiring,
right?
And they're taking a lot of this institutional knowledge with them. So, for every 5 new kids that enter the industry at 18, 20, whatever, 25, you've got 10 more retiring at 60, 70. So it's very much an industry that is very upfront that we need to recruit, we need to make construction cooler, more awesome, more innovative. It's an alternative to going to college, things like that. And it is very much one that is ripe for technology because of that. It's just the pure need for manpower.
I have a curiosity question. So are there more or less construction going on now than there used to be?
Oh, there's way more construction, even with, a mild recession outside of that 2008, 2009 recession. I mean, that halted things and then it picked up pretty quick. So there's more projects going on. I mentioned a while ago that it takes longer to build things. Buildings are more complex than they ever were. Just everything is a little more harder, more complex, more logistics, things like that. But so it takes more bodies to do certain things, but we are doing less manual work. But it is something that just it's an interesting industry of there's so much technology, or there's so much room for technology, and it's really the industry, as much as they've done the last 10, 15 years, the previous 100 years, they really weren't innovating, and it was very much known as a laggard industry of technology, and got far surpassed by agriculture decades ago.
Yeah.
And now is kind of really fighting back and kind of having this renaissance, I would say. And now you're seeing a lot of these larger GCs that have construction technologists on staff, and they kind of have this hybrid role. They're kind of they're not IT, but they're not operations, they're not accounting, they're kind of in the middle of all that. And their job is essentially just go find technology and implement it in the field. And it's a really cool role.
So that's interesting that construction is kind of paralleling nursing in terms of the increased demand, less workers.
Oh, yeah.
So it's going to probably already creating kind of this thinning bottleneck of demand versus what they can do. So actually, I think the augmenting point probably could be expanded on just briefly by saying that when we say augmenting, we're really referring to robots that can do the kind of tasks that basically free your people up to be able to do the things that only they can do.
Yeah.
So that anytime you have a robot that is either going into a space that a person shouldn't have to go, or is doing a task that is menial, dirty, dull, or dangerous, and frees up your personnel to be able to do the things that only humans can do, that's where they really shine and show their value.
Yeah, and we're going to show a lot of examples today. This is kind of just not a deep dive, but we're kind of a look into what robots can do in construction, and really the ones that people kind of take for granted, some of the smaller roles. I think a lot of people know things like the dusty robots and rugged and things like in HP that have the ones that print on the blueprints on the ground. We've seen the J-Bot from Hilti and stuff like that. I mean, a lot of those are very well hyped, and rightfully so. They're doing a great job, so we're going to kind of give us some different examples of robots to kind of fill in some of those gaps as well and help, the safety aspect, the augmenting labor, things like that.
So you hear the term autonomous all the time, all over the place. What are some different ways that robots can be controlled?
Well, and I love that we picked this picture too, because this robot's both. Direct control is essentially that user who's operating a remote or an interface, and they're controlling the robot. Think about a remote control car or even a drone that somebody's flying. But even the drones nowadays have this whole autonomous, and you can set a schedule or navigation path that they can then hop up and go, and there's no one actually flying them. They can check in with that. So, and then there's a lot of gray area in between that of, is there a robot maybe following a person that's got a beacon on them? So the robot is autonomously being navigated, but it's still being controlled by the human. And sometimes autonomous, it just has very simple things. There's things called co-working robots. There's a huge gray area when you get into autonomous. We're starting to see a little bit more definitions of the different levels of autonomy, mostly self-driving cars. I mean, that's a very high end of that. But most time when people say a robot is autonomous, they're not really getting to full autonomy just yet. We're working on a few. We'll have a few examples today of full autonomous robots, but there's also some robots who kind of be either or. Like this one here is one of our material handling ones that we'll show. it can be remote controlled, or it can be autonomous and set up on a path and kind of do what it needs to do.
Okay, so a worker can be either augmented by being freed up for a task with automation, right, or they can be augmented by directly controlling themselves into a place that that they don't need, that they shouldn't be. Okay.
Yeah.
So let's talk about some real world examples then.
Love it. So love this shot. It's always fun to see.
So I mean, like we said, construction is one where they want to see that something works before they adopt it. So fortunately, robots have been operated for a long time. So I think we've got some good use cases that people can chew on and start their brains turning. So what is the first?
I want to pause on this picture, particularly one is I love construction machinery, but it's sometimes robots aren't massive. The J-Bot from Hilti is a big robot, and it needs to be for what it does. This is a small robot that is 15 pounds. I mean, it's something you can carry around pretty easily, and it's so sometimes I think people forget that when they think robots, they're thinking like Rosie from the Jetsons, or some big a big humanoid. A lot of people just jump to humanoid, and we'll share somewhere that kind of fits in later. But some of these robots are small. I mean, even drones. Some people, most people think drones are, they can hold in their hands, and there's some drones that are big as their car, and there's also some little drones that fit in the palm of their hand. So robots can kind of go the same way, and they different uses for different needs. And we're going to start off with some of the small ones.
Okay.
One of the big issues we talk a lot about, Patrick, is confined space.
Yes. So a confined space is anything that is defined basically as limited means of entry or exit, is large enough for a worker to enter it, but is not intended for regular continuous occupancy. And I say that there are a lot of spaces like that qualify within construction. And a lot of the dangers that are associated with confined spaces are that either they can be spaces where if a person has a health issue in the confined space, like I've spoken to lots of companies that say if people's heart rates are usually elevated anytime they're in a confined space, and if they have any underlying health conditions, that can be exacerbated by working in confined space. So there's just the health aspect, but then there are spaces that typically can, because they're confined in their area, they could either have gas leaks, they can encounter toxic gases, corrosive chemicals, flammable solvents, machines can start unexpectedly. And another thing that can happen is that a worker in that space can accidentally make something bump loose, which makes gas release. So the percentage rises whenever you're doing work in a confined space.
Yeah, and I'm glad we're starting off with confined space too, because I think it helps set the tone of what the environment is. A lot of people, when you think construction, you're thinking new construction, vertical construction. Right. We're building mid-rises or high-rises.
Out in the open air.
Yeah, but we're also building roads. We're building ditches. We're building factories. We're building mining. Is sometimes goes right into construction. We're going into sewers. Like there's just all this infrastructure that's in our world that we take for granted when we flush a toilet or run electricity. That's all construction at one point. So and there's new construction, then there's maintenance, and then there's repairs. So there's a lot of very dynamic environments, and that's one of the other challenges with construction is it's such a dynamic industry. I was talking to somebody the other day, and he's former military, and he's talking that's why he loves construction, because the military he thrived in that dynamic environment, and he loves that with construction. He doesn't want to sit behind a desk, and it's a good win and a good move for him to transition to the construction industry. So we kind of talk about just teed up was the sewer pipes. This is a big place that I don't want to crawl in.
This is an interesting one because I get a lot of calls from within the construction industry of people who have a sewer pipe, or they've got some kind of drainage pipe that once they've finished construction, they have to inspect it. Like they're obligated to inspect it. So really everything soup to nuts has to be inspected after the end of the construction project. But their current way of doing it is via kind of CCTV camera feed that's been around for decades, and it requires special equipment, a special van that costs, I think, something like $1 million or something like that. And it's got to be scheduled. They got to come out, they got to inspect it, and it costs them money every time they have to do it. So being able to just be able to inspect it, get it done, move on, write the project as done would save both time and a lot of money.
Yeah, and I know this one's a little bit more of our workhorse one. Like one of the things we've heard from the customers.
I love this robot.
That they get in the sewers and there's something blocking the water. well, somebody's blocking water. That's why they need to get in there. So
Right.
they'll send this robot kind of even just push out some debris and things like that. And obviously we've got some smaller robots, but this one is actually watertight, so it can handle a good bit of water, and it's tethered because you're going to lose signal in that that concrete bunker essentially.
Yeah.
So it's really interesting to see that this is one of those things I think people just take for granted, that just water works. Rainwater goes away, and they kind of forget that somebody's got to go down there and fix it. So.
And electronics and water don't usually mix, but the ability to be able to watertight robots is something that's feasible and done all the time. So, like you said, like Perrin said, this is our workhorse for going into wet, nasty. We've even had situations where this is inspected pipes that periodically water will be rushing down the pipe, and we'll actually submerge it temporarily before the swell goes down, and it's fine. It can handle it.
You were telling me, so it wasn't necessarily construction, but maybe the precursor to construction, but one of the Department of Transportation is why they were getting one of these, right?
Yeah.
You want to share the catalyst of what was?
Yeah, that is actually a really fascinating one. So in the state of Pennsylvania, they have like thousands of bridges, over 1,000 at least. And I didn't realize until I was speaking to this guy that our customer, that basically the entire state of Pennsylvania is vibrating because of all of the coal mining that's gone done, catacombing underneath the state of Pennsylvania. So all the bridges that were constructed years ago now have just been constantly shaking over the years, and that creates potential damage in the pipes that go underneath the bridges. Every time it crosses a gulch, there's usually a pipe that goes underneath the bridge. And so it's a person's job to crawl through these pipes to inspect them. And he said that 3 of his colleagues in his industry lose their life every single year. So he himself had a scary situation happen, and he was looking down the barrel of a project of inspecting all the bridges across the state of Pennsylvania. So he basically asked himself an important question, which I think is important for anybody in an an industrial arena to ask, which is there a better way to do this?
Yeah. I think that's the big thing, is just forgetting the status quo, forgetting we've always done it this way. Is there just a better way to do this? And that's a good story. I mean, 3 might not sound a lot, but 1 is enough. Like, can we prevent somebody from passing away due to something that could essentially be prevented? That's a big piece of this. So,
and all it takes is one advocate within an industry to basically say, is there a better way to do this? And then spearhead that within his own industry. And now that individual is kind of a pioneer for, now people are asking, they're watching him very carefully to see whether they can replicate this themselves. What are we looking at here?
So this is under a crawl space actually of a porch, but we've actually sold a lot of these same robots that to home inspectors, plumbers, things like that. Some on the residential side, some on the commercial side. But this is a big one of those places that I'm like, nope, I don't want to go in there. I don't care if it's my house or what. Like, unless there's a water leak or something, I had to go in there. I don't want to go in there. But if you're a home inspector, you have to go in there. That's part of your job.
Unless you really want to visit the family of raccoons that lives under your porch.
Or worse. Yeah, we've heard some horror stories of the family that had rattlesnakes to get rid of the rats and forgot to tell the home inspector. And
that's my favorite.
One home inspector a couple months ago, and I was like, "What's the craziest thing you found a crawl space?" He's like, "Homeless guy that's been living there for a few years." Like, I just dumbfounded. It's crazy. I mean, this is not even I think most home inspectors agree this isn't even a bad crawl space. It's a little rocky if you're going to crawl on your stomach, and coveralls doing this. But the other cool thing is,
I'd rather not get poked by rusty nails. That's happened to me before, and the tetanus shot is not fun.
Yeah, and you don't know what's in here. You don't know if there's a live or a dead animal under here, and things like that. But here's the other thing: you're getting video footage. So this is another really good thing if you're doing a renovation of a building, that you now have video footage. If you just have somebody go under there and crawl with a flashlight, they might bring a phone with them and take a picture with it, but it's still not going to be the documentation that you have here. This can give you, beam by beam documentation so that you can actually do better planning. So that's one of the huge things, is just that video documentation that you're not going to get by a human going under there.
I would also say that there's the human element involved. Is that I had yet another job where it was for an HVAC company where I had to crawl under houses, and whenever I get into that space, I'm just trying to get it done as fast as possible because I don't want to be there. And it's not that I'm scared. It's just that I start rushing because I'm very uncomfortable, and I'm just trying to get it done as efficiently possible. Whereas with this, you've got HD video and you can take your time. You can look at stuff.
that's a good picture. So we got it actually from a customer off of YouTube. But it was also cool. You saw him at the end. This is a good example of augmenting labor. He's still got to do the job. He's still got to do this crawl space inspection, but now he doesn't have to go in there. And some of the people have even told us, well, our home inspector, even contractor, this isn't going to do anything. This is just a small robot with a camera and a flashlight essentially on it. But it does that initial inspection. It's not going to go do any repairs. But now you know what tools you need, where the issue is, and now, so it's going to really save you. And I've had a few home inspectors even tell me, I can inspect a place like this faster than I can get my coveralls on. Like just by the time they get suited up, get in there and kind of get mentally prepared to go crawl in there, they can go off at, not to mention how many crawl spaces you can't fit a child in. They're older homes that, accessibility is a big piece of one reason why that robot's so small is just to get it into the crawl space in many cases.
Yeah.
So want to throw in some residential stuff as well, but this is one that we see on the commercial and even industrial side. We've got I know a few industrial clients that use this to go in their crawl spaces or even under their machinery. So
and I'm curious, just a curiosity question. So when you've done new construction, you still have to inspect crawl space areas, right?
Someone will
leaks.
Depends on the client, depends on the state, the city, the state, things like that. But yeah, you still want to do some type of inspection, and more and more building owner clients want video documentation or 360, and we'll kind of get into that a little bit later.
This is a great video. This is a customer of ours that on the subject of construction, this is for preventative maintenance. So as a part of the fabrications or the manufacturing process for their metal, they have to inspect these flues, which are about 100 feet, and then it takes a right turn and it goes another 100 feet. And their current process for doing this historically was to actually find the smallest guy in the factory and cool it down to as cool as possible, 100 degrees, and then have this poor guy shimmy through this thing squeezed in there.
Over those little bricks too. Just want to.
With the ash falling in around them. They've had a few guys panic in there, and they basically they read the writing. No accidents had happened yet, but they read the writing on the wall that this is just a bad scenario waiting to happen. So is there a better way to do this?
Yeah, so just for reference, this is about 20 inches wide by 30 inches tall. That's it. And the whole inspection, the whole video of this one, you guys saw it looped already, but the whole video is about 45 minutes. And they said this was way faster than a human going there. So a human would be in there for just hours, versus this little robot goes in there for 45 minutes to an hour, and that they can go do their inspections. And again, video documentation that they weren't getting before. Before that was one of their struggles was, okay, there's an issue here. How do we document that? So that's a huge issue. Is if we talk about maintenance and just regular inspection stuff, is just how do we document this whole thing? And now, this building engineer, facility engineer, the next time they go do this, he can pull up one video and pull up another, and now he can compare side by side what, this is essentially the control. What's worse than it was before.
And they don't have to take as much time to cool it down because they're sending a robot in, so they've already saved millions of dollars. Which is, I love it when the ROI makes sense like that.
Their shutdown or turnaround is a lot shorter. So we're going to continue on with some confined spaces.
This is a good one.
Go to the other one. So this one, actually, if you go to our YouTube channel, actually is interactive. You can control the little cursor on the top left, but we did it here just for the video, so we're not fumbling essentially. But this is above our CEO's desk and his drop ceiling. So one big issue is drop ceiling is what's up there. And you're popping up one tile, and you go look around with a flashlight, maybe take a couple of pictures, and then you close the tile, go down the ladder, move the ladder 10 feet, and pop up another tile. And here you just put the robot up. And obviously there's obstructions, there's lights, there's air conditioning, heating, things like that. But you can get around a lot of places. And that's when we go down, the black thing is actually the ring light that we put on there on the robot. So
this is a corporate espionage POV, right?
No. So, but I will say I was very impressed. And the reason I say this is above our CEO's desk is, one of the first comments most people say when they see this robot, and they're like, "You put a robot on ceiling tile? It's supposed to be rated for 10 pounds. The robot's 9.9, and the CEO put it above his own head." So,
okay.
So
this is light enough that it can crawl around the drop ceiling without worry about it falling through.
Correct. The difference between this robot and the one before was this one is one of our tracked robots. It's got a little bit more of a base to it that it can get over these. It's not just four wheels. It's got tracks. So same basic concept. We have these two crawl space or confined space robots, and this little attachment of the light ring allows us to see up there.
It's interesting. Our CEO is a structural engineer, and he actually told a really cool story about a time he was actually doing an inspection and was walking along. I think it was like an I-beam, and he noticed the I-beam was kind of moving, and he was about 50 feet above a floor, and he noticed that the other end of the beam had completely disattached from the other end and was just kind of wiggling and swinging. And with doing something like this, being lightweight enough to be in the crawl space, you can actually see, as you can tell from this, in HD video, every nuance and every aspect in that crawl ceiling. And this is nice, of course, when you want to be able to crawl the whole crawl space without having to pop your head up like a gopher. But this is especially essential if you have one of those atrium ceilings that's 50 feet above the floor of an atrium, and you actually have to get one of those cranes to get in there.
Yeah.
So,
and we've had a few IT companies actually get this, and they basically strap a wire to the back and they start running wires this way. Because you imagine try to inspect drop ceilings, one thing, but you're trying to run wire, you now pop 10 ceiling tiles every 8 to 10 feet, and you're just running wire from one hole to the next, and it's a pain. So they're popping wire on these, and it's
and I think for those that don't know, so this is a 360 degree camera, right? What does that mean?
So essentially it's got two fisheye lenses, one on the front, one on the back, and it's just running video, and these fisheye, and the software will put the other. So this is the software that's native to that 360. You can then import it to a reality capture software. We're going to have a whole section on reality capture coming up.
Okay.
But this is just this fits more of that confined space, but we can do this. And like I said, when we import it to YouTube, those controls work. We just trying to simplify our lives a little bit. And
well, what about other areas like ducks? There we go. It's almost like I knew that was coming up.
So let me ask you this, Patrick. Die Hard a Christmas movie since it's a couple weeks till Christmas?
Yes, it is a Christmas movie. Yep.
That was the first thing. I was like, I've seen this video a dozen times, and it wasn't until now that we're a few weeks from Christmas, I'm like, yeah, Die Hard.
It is also a 4th of July movie, depending on which one you're watching.
Yeah. So here's what I mean. Has anyone ever seen the coils of a heater that close, in HD? No. I mean, unless you installed it, you probably have it. But this is a robot that was able to crawl through there. It's the same crawl space, confined space robot, and it's a little tricky to get through those little vents. But so it takes a couple of tries. But
what I love about the robots is that, and this was a question I got at the trade show I was at a couple of weeks ago, which was when you're looking at the view and you see the edges that you see on the camera are actually the edges of the wheels themselves. So you can actually very intuitively, if you think that you're going to squeeze through, then you can see the edges of your wheel. You can actually get through them pretty efficiently.
And you can see it if you look at the bottom left or the bottom right, you can actually see the edge of the wheel.
Yeah. So. Now, so inspecting ductwork, I have heard from some construction companies I've spoken with that they do need to inspect ductwork after it's been installed. Yeah.
I was at a conference in October, and a guy was saying that he's got to go. His company got hired to inspect an entire, not just the hospital systems ductwork.
That's a lot of work.
He came. He's like, "Do you guys have anything to do?" And I literally just pulled up this video. I'm like, "Is this what you want to do?" He's like, "You can do that." And it was just this. He was like, done. Now he wants me to build a magnetic, or us to build a magnetic one that go vertical. That's one thing we can't do on that. But we do have.
We have done wall crawling robots before.
Yes. But we do have the walls, physics we got to deal with, and then it's construction. So let's talk about going under machinery.
Yes.
One of the things I've seen, some really good heavy civil contractors do is they've really improved the efficiency by making sure the machines are operational. So they do a daily check, inspection, things like that. Mm-hmm. So, but this is one of the things that's hard to do. How do you check underneath the equipment? Is somebody really going to crawl under there and look? Does this need to be greased? Is there an issue here?
How often do you see workers crawling underneath heavy equipment every day? Okay.
Yeah. I mean, there's certain things that they do daily.
A lot of the stuff is underneath it, right?
Correct. Yeah. And obviously it's got mud. We didn't clean this thing off or anything, but you can still see if there's any issues, things like that. And again, it's in HD. You've got documentation of this. So, and you could potentially crawl under a whole fleet of these pretty quickly. So.
Well, I was researching on the CAT website about it was an article about the importance of regularly inspecting your heavy equipment, and it was interesting to me to see that it wasn't simply a matter of lowering your repair costs by being able to catch things before they were a problem, but that if you had issues that were just about to happen through poor maintenance and non-inspecting equipment, then that could constitute a serious health and safety hazard.
Oh yeah, I mean these
well.
machines cost millions of dollars, but they're also being operated in an environment, and there's somebody operating, and there's people around them. So if one of these machine breaks, you could be have injuries in the surrounding environment because they're not. So the machines wouldn't be responding the way they normally would.
So the argument being a cost-effective robot, and the ones that, for example, the one that is doing this inspection is probably our most affordable robot.
Yeah.
You can just literally do an inspection like this every day in like a minute.
Yeah, this is the same robot we've been showing. These have the two versions, the 4-wheel drive and the tracked. Both there are differences with them, and this one is the 4-wheel drive one we saw at the beginning of coming out of the machine. Essentially, this is just the inside video. This is what the robot sees versus that opening shot we showed the actual robot. So I want to move on from sciences. We got some other cool stuff. So Patrick, you haven't even seen this image because this was taken yesterday. So
it's a new mast, right?
Yeah. So this is a new thicker mast. Our team they're testing this out in Chicago. It's one of our new groundhog, we call it, is our reality capture. So hopefully most people on this call or this webinar know what reality capture is, but it's essentially going through a facility and using either laser or a 360 camera, and that's what's on top of that robot, in surveying or inspecting the entire facility. So this is something like a manufacturing facility. This is an example actually from Matterport's website. Like, you can't take this shot. This is impossible. And they've kind of created this dollhouse view is what they call it, where you can do an aerial, then you can zoom in and see any spot of this. So we definitely see this on the facility side, but in construction, we're getting required to do this.
I have talked to fewer and fewer construction companies that are not yet aware of the fact that all of their competitors are starting to do reality capture. Could you talk more specifically about why capturing, or there are other words that that people have probably heard: the reality capture, digital twinning, all those kinds of terminology.
Yeah, so
but why would that be helpful?
This is an example of a digital twin. It's essentially a twin of the actual environment digitally. It is a very good name. The two main use cases that we see this with buildings is more on the facility management side, where they're doing monthly, quarterly, annual inspections that they want to just document what's there. Not having somebody walk around with a camera, or even it was reality capture software. The current way, you'd either walk around with a tripod or a monopod and try to capture this entire facility, or you drive a robot.
Right.
But with construction, the interesting thing is it gets really dull, because if you're only doing that once a year, it's not so bad. It gets a little dull, but it's not so bad. But in construction, we've seen, especially with COVID, that a lot of the building owners or developers couldn't make it to the job site. So, and if they have a job site out of state or even across town, they were relying on this software to basically show them the progress. And we call it progress monitoring, essentially, for that. So now a lot of these developers and owners are now requiring contractors to do weekly scans. And the challenge for a lot of the GCs is, like we said, it's dull. You're literally going to walk around a job site with a tripod and take these 360 photos. But it's essentially something you're not getting paid for, because it wasn't really in the scope years ago. This is kind of a more, the technology's caught up, but it's also a bit of the post-COVID, people aren't traveling as much. So
you have to pay a person to every single week be doing a scan with a tripod, moving it around, do a scan. And if you have multiple job sites, that person has to go around from job site to job site. That can get pretty costly.
Yeah, there are services that people will do this. There are some companies that will have one person do this. Most of the construction companies we talk to, it essentially falls on the superintendent to get it done. So the superintendent on the job site has to get this done. Maybe they'll push it down to a project engineer, intern, if it's the summer, things like that. But it still takes a couple hours, for a decent sized project to go get done. And I was even talking to a real estate developer a couple months ago, and she was telling me they actually have 3 different reality captures on a job site. I was like, what? That's absurd. So the general contractor does one, as their scans. Her, as the developer, does a weekly scan. They pay a service to do it. And then the building owner that the developer's building the robot, the building for, does it too. And I'm like, why 3? She's like, well, trust. Because the GC, that general contractor, was doing them on Tuesdays, and then all of a sudden it slid to Wednesday, and then Thursday, and all of a sudden they missed the Friday, went to the Monday, and they missed an entire week. And are they just busy, or were they behind and they didn't want you to see it?
It just
So
got
that's
deprioritized, right? So, but
it's a low level task. Would you rather be swinging a hammer and getting the work done, or would you rather be documenting the work?
You got to get it done.
So it's a trust issue. So now we got one place that got 3 different reality captures. Like that doesn't make sense. And that's even more data. And now we're getting data overload in some of this. And but the other power of this.
Oh, go ahead.
So the other power of reality capture is if you're doing this during the progress, like while it's getting built, is once that sheetrock's up, you don't know what's behind the wall. But if you've been doing weekly scans, you can see exactly what's behind that wall and exactly where it is. So if you need to trace wires,
who is that data useful to? You said stakeholders for building trust, but anybody else?
Generally, like someone who can kind of maintain that building. The developers are looking more just to make sure the project's on task, going to be built on the right time, quality, things like that, quality control. But it's whoever's going to take over the building and be that like the head facility manager or supervisor. They really want to know what's back there because nobody wants to rip a hole in a wall that they don't need to. And that's very much the old method. So you really get a time lapse essentially of what's behind there. And there's some software that would literally build a timeline, and you can walk around this whole facility and in 360 and kind of do a virtual walkthrough. Like we've seen a lot of it. Matterport's really done a great job with that in the real estate market, walking through apartments or houses, things like that. It's
so this same data that you're taking has multiple values from multiple different stakeholders.
Well, you were telling me even a safety
even
guy,
the customer,
even a safety guy was interested in it. So
he was looking at the data. He just happened that day to have access to the data that they were using for progress monitoring. And of course, since he's a safety guy and he sees everything through the lens of safety, he saw something that no other stakeholders had seen. And he said, "Oh, we need to fix that." And the supervisor kind of chuckled when he came to him. He kind of chuckled and said, "You've been looking at the reality captured footage, haven't you?" And he said, "Yeah, I caught something."
And it wasn't anything big. It was like a hole essentially for I think it was a staircase that wasn't built, but it was just like add some barriers around it just to block it. It was a simple fix, but it's something that kind of everyone took for granted because we'll fill it in eventually.
Well, and then
so I do want to show.
Go ahead.
Yeah, I do want to show a little bit how this robot works. So this is our autonomous version. The one that we saw earlier. So as it's going down the hall, it's navigating here, right in the middle. So that's what it's seeing through its lens. And then this is more of the view. If you look on the bottom, it's mapping. I'm gonna pause it real quick.
So it's mapping and navigating.
Correct.
Kind of similarly to how we see the world. We are looking at the world and navigating it. Based on what we see. You
see on the right here, this is WP1, waypoint 1, waypoint 2. That's here, waypoint 1, waypoint 2. And we're navigating. This is our own shop in Raleigh. Going around. The other one was a job site out in Chicago. But you see that black is what it sees through its wall. These yellow lines where no man's land. Don't go here. And this is us testing it. The real reason we didn't want them there. Nice. Maybe there's somebody working here and we don't want the robot bugging them. But one of the things.
So it's trying to decide how to get to where it's been told to go to, but it has to decide that while not passing those yellow barriers that you put up.
The robot has basic obstacle avoidance. So if somebody walks in front of it, or there's a tool down here too, for it's trained to go around those kind of things. We also may help set those settings or determine the settings for, does it go over an extension cord? Does it go over a hose? Like how high of ground clearance do we control it? And things like that. So like job sites are full of hazards, and we don't expect to have a perfect path essentially of that. And I got a clip later on. I'll show you. I think it was humorous. The guys intentionally drove it up a gravel pile.
So you could hypothetically, as opposed to paying a person to basically, I can't imagine how costly it is to set up tripods every single week on every single job site. You can hypothetically, you can have a robot that is on a site come awake at a certain same time every day, take the scan that's needed, and then just go back to its starting point. That's beautiful.
Yeah. So essentially, you think of this instead of the robot, think of it as basically an automatic tripod.
That's great.
And each one of these waypoints for reality capture purposes, this is where it would shoot the 360. Because every software is a little different. Some you need to shoot a photo every 4 feet, some every 5 feet. Some take live video, and their software can take it from there. So we're essentially setting the waypoints. And if that waypoint's off, we also set the control essentially how far away can it get. And again, that usually ties back to that reality capture software that we're ultimately trying to get this into.
Right. So that same person that's wasting all that time traveling from job site to job site could be managing all of the scans on all sites.
Yeah, what
It's
we
great.
hear is it generally take for an average size project, and average is obviously different for every company, but I guess what we hear is generally this scan would take an hour to 2 hours every week for someone to do. And if it's a job site superintendent who usually has that task, it can take longer because everywhere they go, they get stopped because they're the superintendent.
Of
So
course.
it's and we were to someone the other day and working with a construction technologist, and we're talking about bringing this one of their sites doing a demo. And he's like, one of the pushbacks is like, we want our project engineers to walk the job site and do that. It was kind of like they're forcing their project engineers to do it because they're young, they're trying to learn the industry and all. And they're like, but you really want them to walk around with a tripod, or you want to walk around and actually learn something?
Yeah.
It's like it was kind of the objection wasn't the objection. It was just we need them to walk. And the other thing I think is interesting with this, which has kind of been an issue with some robotics and construct. This robot is unassisted. There's not somebody walking behind it, babysitting it. It's trained not to fall off the edge. It's trained to no man's land, things like that. And we, like I said, we set some of those parameters, like the ground clearance, what it goes over, what it doesn't go over, how far around it can go, things, all that stuff. So those are all controls that we work with the client on.
Now, do you use the same robot for every type of job?
So you can. We've had a few customers ask about basically taking this job site from job site, or floor to floor, and as if it's a really big building. And you could save different navigation paths for floor 1, floor 2, or job site A, job site B. This one's priced enough that most of them are basically planning to just put this on a job site, and it would just wake up Tuesday at 4 and go.
Gotcha.
Most of the GCs we talk to want to have this after hours once the trades are done, not actually for the robot's sake, but more for privacy for their own people. So that's another issue. If you're walking around a job site with 360 camera and everyone's working, everyone's in the pictures.
Gotcha.
So it's, I know, Pat, you were telling me a story. You got a customer that does this they survey boats. And one of the reasons he wanted is he was tired of hiding under the tripod or trying to find a hiding spot. So he doesn't use an autonomous one because his environment changes every day because he's only inspecting these boats like once a year. So he uses the remote control version of the same kind of robot. So it's essentially a tripod or a monopod on remote control that he can move around and take his shots.
I understand. I get tired of playing hide and seek with my kids too.
Yeah, so it is really cool, and I love
That's
this
pretty
video
cool.
that we're doing all that. So I do want to say next up, as we were getting 360 was phase one. Next up, we are going to work on laser. We're talking to some of these companies, but how do we then do a laser scan with this? But that one doesn't have since the monotony of the weekly progress with the 360, but more people want more accuracy. So
I see.
Yeah, so we're not
different tools for different purposes at that point.
And even this one, we've already got kind of our base models. These are robots we've had for a while of different sizes. Part of the robot we're currently using was almost too small. This footprint's too small to put a laser scanner. Some of these laser scanners are $75,000. It's I've let out somebody tell me it's like not putting a $75,000 camera on a $5,000 robot. Like, I don't blame you. Like, so we have other ones, and even this one, it will elevate 4 or 6 feet. And this is more for really tall ceilings, like manufacturing facility, industrial, nuclear, things like that. So we can automate at certain check waypoints. It would raise up, lower, things like that. So in this one of the challenges with laser scan is the way these work is they essentially go to a place and then the camera spins and does the 360. But it can sit there for 10, 20, 30 seconds, depending on the camera and the level of accuracy you want. That's really boring. It's not just going to take a 360 and then go to the next one and go to the next one. You literally got to wait for the camera to work.
Yeah, that's not what I went to college for.
Yeah, and so there's definitely environments that a robot's not going to take. It's just you need a trained laser scanner to do this, like a person. But there's definitely some stuff that's just really kind of beneath a trained person that's just really boring. And a lot of laser scanners we've heard is they basically have 2 tripods and 2 laser scanners set up as they work on one, and while it's scanning, they run to the other one and operate that one, and then they move the other one and run that one, and it's this constant game of like leapfrog. And that's the only way they can kind of get things done fast. So I just sitting there waiting for it. Well, the robot's not going to get bored, and it could potentially even do this in the middle of the night while the facility's closed.
Yeah, I don't think we should program getting bored into a robot. I don't think that would be
all right
helpful.
So Patrick, I am seeing we're running a little behind.
I know. It's when you and I start talking about robots. It's always the problem.
I know. So let's talk some fun stuff. So material handling is another one that comes up. There's a lot of inefficiency in job sites of getting materials from, like, say, the drop zone to the staging area.
Right.
So this is a robot. You can basically add any crate on top or anything you need on those rails, and it can handle outside and just carry stuff. So there's two options on this one we've seen that we've talked to people about. One essentially is at the drop zone, the robot's there, and you would hit a button, and it would go to stage area A, stage area B, and somebody would unload it. And the other one is you would do the follow me with the beacon.
Right. And getting material from A to B is not unique to construction. It's the same. It's the same in manufacturing as it is across the board. You always got to get something here to there, but you're not. Anytime you're just moving material, it's not productive time. You're not getting paid to move material. You're paying people to move material, but the overall project is not getting paid when you just need to get something from A to B. So automating that or making it at least something the person, whether follow me mode or just take this material there, you're automatically there ROI built in. You're already saving money.
Yeah, and that follow me
pays for itself.
Takes that weight off, and this is just the bigger version essentially. That robot I showed you was 300 pounds, can hold up 250, 300 pounds. This can hold 500, 700. So that's bigger footprint, more size. Yeah, this one's a big boy. So
now we also talk about, when we talk about risk, there's obviously safety risk, but then there's also loss, right? In construction, that's a big topic.
Yeah. No, and so this is one that we actually do a lot with police and security departments. But if you're working a federal job, sometimes every vehicle that comes on site has to be inspected. That takes a lot of time. If you think about how many materials, how many workers are coming into the facility, and every vehicle has got to get inspected. So this is actually the same robot we've been talking about for crawl spaces and drop ceilings and air ducts and all that. It's the same robot. It can also go under vehicles. It's the same example of the heavy machine. And then, more of a patrolling robot. This one just goes around, basically puts up a perimeter.
So theft on construction sites is a huge problem, right? I mean, I always see them lifting their stuff in the air at the end of the day.
Oh yeah, it's a huge issue. You'll see them back a trailer up against another machine, things like that. And even some of the tools, even the handheld tools, like the Milwaukee, the DeWalt stuff, they now have smart devices essentially that are geofenced. If you pull them out of the geofence, they don't work. Like they're getting really smart tools, but you still have some basic protection or even vandalism. You're not losing anything, but it could get vandalized.
Right. So I was passing a construction site the other day where I saw they had a big pile of gravel inside the construction site, and I saw a lady with a Subaru with the back of her hatch open, and she was shoveling the gravel into the Subaru, and I was like, she doesn't look like like she belongs there. She just needed some gravel.
Yeah,
couldn't believe it.
I mean, I'm sure we could get a lot of stories from people on the team. And this is actually one of our utility customers, Southern Co. And they are using a remote control version of this, the monitor gas when there's an outage or something breaks essentially at a substation. But construction is one thing. Certain areas that you work could have, if something goes wrong, have gas that you don't see. So to have a robot basically patrolling the area, much like our security robot, potentially even the same robot, could patrol and just do a gas sensor, or there's a lot of sensors you can add to robots. The challenge for most people when they have sensors is they're stationary. Well, if you add it to a robot, it now becomes movable and it can follow a path.
The policy of this customer is that they have to confirm or deny the presence of gas before they send workers into that area. So this has saved them a lot of maintenance equipment that they had to basically suit up into before to do that. So now they can do it faster and get to work.
Yep. And the alternative is old school gas mask. So now the real fun stuff, the future.
What is that?
That's a no-armed humanoid robot. So we got to teach the robot to walk with legs without his arms, because people actually use their arms to walk. So the programmer's thought is if we teach you to walk with no arms, we add arms, it actually helps and they can actually carry stuff. So
well, that's good, because a lot of people talk about the future of robots as robots being dangerous, but this one's quite armless.
So here's a rendering of that same robot. So we are building the robot right now. It's still in R&D, but here's an example like an electrical contractor will look like. We're still finishing out kind of the back, but it should have the operator on the ground operating here. And one of the interesting things, Paddy, we have this whole concept of why would you put another robot up there, but using the same gear that the human would use.
It would. I mean, it's basically the idea that you could you're not replacing a worker. The worker is still doing their skilled work. It's just that they're doing it using the exact same tools, their hands, and the tools to keep themselves safe. The problem with doing this kind of work is that when you're when you have an arc flash, it actually vaporizes metal. And I talked to a customer that fortunately they had a guy, and when the arc was coming towards this guy, this worker, he got as far into the corner of the bucket as he possibly could, and it vaporized his beard, and that was where it stopped. Luckily, before it vaporized his torso. But if you can, you're not replacing anybody, but if you can do the same work with the upper torso of a humanoid installed on a bucket, then why not do it?
Yeah. No, it's definitely a huge thing. And this is another example of, we talked very early on, a difference between autonomous and direct control. This is obviously a direct control. This is not a task that you would automate.
Correct.
Versus a security robot or that material handling, you could automate certain things. This is one that you wouldn't. And we're starting to see these guys on job sites a little bit more now as well. So
I want to see a torso of a humanoid on one of these quadruped robots, like a centaur. I think that would make my Greek mythology come alive.
So this is another robot we've got in R&D right now. These are all coming out for 2024. A quadruped or four-legged robot. It gives us a little more diversity for the dynamic nature of construction. It's one of the things we saw in our fleet of robots. We're a company that has a lot of different robot models. As we're missing one that can really be more dynamic with stairs, elevation, things like that. So it could be an inspection robot. It could be small material handling, but majority of this is going to be an inspection robot, but very dynamic. The main use cases for this would be like petrochemical plant or things like that. There are just a lot of catwalks, stairs, things like that. Big facilities that need to constantly be patrolled. So far, we haven't had any questions come through. We have Aaron Mann in our chat, but if you guys have any more, we just kind of wrap up. One of the things we hear a lot from people is, this sounds really good. I see a use for this. Now, how do I get this approved? So, we always try to help people, help themselves as well. We're happy to help with people do this as well. But here's that gravel picture I was talking about earlier. It's just, guys literally just drove that robot up the gravel.
That makes sense.
One of the first things you need to do is spot the problem. Stop saying we've always done it this way,
right?
And kind of think, is there a better way? And it's not necessarily it's a robot way. It could be a software. It could just be a different tool, a different piece of machinery. But sometimes it can be robots. And robots have come a long way in the last decade. They've come a long way in the last few years, and the next few years will be more so. So it's just kind of really looking for those, why are people quitting is one of the big things. Like, people start quitting jobs a lot of times because they see they're not safe and corners are getting cut on safety. And they're just like, I'm not going to die for this company, which
I have known workers who have talked to me that have changed companies simply because they wanted to go home to their family at the end of the day.
Yeah. Safety culture is a huge thing in construction, rightfully so. So that's one of the things is asking HR, they're specific, asking safety. What is those kind of those, pinch points that you can't avoid right now? Things like that, or even recruiting people. One of the things about construction is it's generally quite visible from the outside. If you're paving a road or building a building, people from the outside can see your job sites. They can see the issues that you're having, and just help with that. And we talked earlier on this industry's trying to recruit more people. Having robots on your site definitely makes it a more appealing industry to get into.
And one of the things that Perrin is referring to is with this section is that a lot of times, our job is not only to, of course, educate people as to the value of robots, but more so to help people understand about how to create the business case for how potentially robots could be useful for them or not useful. But we'll kind of help you quantify the problem, understand how to ask the right questions so that you can, and then in quantifying that, be able to compare and contrast that to the cost of a robot in order to understand what value, if any, that it can provide in fixing some problems. And if the value is there and it makes sense, then yay and great. But you want to break the idea before you buy it.
Oh yeah, totally. And one of the beauties of a company like us that has different models and different use case like that is a lot of times if a robot can work, but there's that little edge that maybe would work a little better if we had a modification. We do modify our robots, and we also do custom robots. So that's actually an interesting part. We've done some proof of concept for some companies. We actually did the first dusty robots. We called it the Laybot because that's what it was. It wasn't a company yet. So we did that about 11 years ago. So and then you want to look at the cost. Once you identify some of the issues, what is that return on investment? Injuries, things like that, and the turnover, all that costs money. Every time somebody leaves a company for these issues, that does cost the company money.
I've heard you talk about how robots are useful for on the recruiting side. What do you mean by that?
Oh, it's one of just appealing. Generally you're trying to get people that are 18, 25, interested in construction, or even maybe 16. You're trying to get them to look at construction as a career. These people that grow up with computers or growing up with iPads and Androids and gaming systems and all, like they're not scared of robots as maybe an older generation is. They're not technology natives essentially as the younger generation is. So
I see.
When they see this, and this is one of the advantages some of the larger general contractors have with the smaller ones. They have this stuff. Like we've actually joked where it's a competing robot that it's expensive, so it generally sits in one of 3 departments: is the construction technology officer testing, marketing, sales, marketing, and then recruiting. It actually isn't in the field. That's one of the big things with us is we want to build robots that work. It's really our mantra: robots that are built tough and they can work and survive this, but they also have to be priced the right way. Like our COO Steve would say, you don't need a $200,000 robot for a $20,000 problem. And that's why a lot of our solutions are sometimes really simple, because you need to have a robot that you can afford to get the job done. Not all of our robots are. Yeah, not all of our robots are $3,000. Some are much more, but they have much more return on investment because they can do more.
Right. I think it's important just to not just when you're looking into researching whether robots can add value. I think it's important to pay attention to the quantifiable aspect of that, so that you can track it.
Yeah,
and
totally.
then scale
it's helping.
Yeah. Yep. Exactly.
And sometimes you're not offsetting. Like we talk about augmentating workers. You're not necessarily offsetting their man hours. Like the reality capture. We do have a remote control one. You still need someone to drive the remote control one, but it's a little faster, a little more fun, and it's less dull. So does that task get done more often and get done on schedule because it's being remotely controlled versus somebody walking around with a tripod?
Yep.
It's nothing like technology to say, just let's use a tripod that's been around for hundreds of years. So, and the last thing, you put all this together in basically a business case. This is really an oversimplified business case, but it's really impactful. Get this down to like a 1-pager, 1 page and a half. This is how you present stuff to a COO, a CFO. Here's the challenge. Here's the impact it's having on the company. What is the cost to the company? Whether it's injuries, what's not happening, the requirements for reality capture for clients aren't getting met. What are all the different solutions? Like I said, robots might not be the solution. They could be a different software, different hardware. It could just be a different process. And then what are your recommendations? And then look at that ROI, is that return on investment. So if we make this recommended solution, this is the return we can expect. And this is what the measuring stick should be. Much of the robots we work on are going to be more focused on safety. And that's a little easier to say, is if we can reduce the safety risk. Some safety firms have levels of different risk. If we could help reduce a risk, especially if it's essential death, that's obviously a huge cost to the family, but also the company.
Prefer to get a call before that point, but yeah.
We've unfortunately had a few people when we ask, why are you looking at robots? That is the reason why we've lost somebody, or somebody in the industry, or somebody at a different facility, things like that. And we hate to hear that, but we are happy to hear that they are trying to figure it out to prevent it from happening again.
We want to equip internal advocates. If you're trying to make a business case within your organization, we like to equip you. So if you are looking for real world use cases and actual stories, because stories are compelling, just ask us, and we know all the stories because we talk to them every day.
Yeah, and I'd say, this is a webinar, but with doing this on YouTube, it gives a little bit more accessibility, makes it easier for people to look, but it doesn't quite have the back and forth of Q&A. But feel free to reach out to the SuperDroid. There's a lot of ways. Our website has basic general
social
forums.
Media too.
Social media is a great way, but Patrick and I and our team, Ben and Aaron, are monitoring. And so if you got questions, hit us up on any of these channels. And just we want to educate. We want to help you guys make decisions, or be informed to make the decisions. And just our mission at SuperDroid, and overall even our parent company Rex Technology, is to make the industry safer and more efficient. So we see that. So how we're going to do that is with robots.
Well, thank you for all of your expertise, Perrin, and thank you also for joining us in this webinar. And I hope that it was instructive. But if, like you said, if you have any other questions, reach out to us directly or use any of our social media channels. We're happy to chat. Sorry about the cough.